We got the recording work. Hopefully this thing still works. So those guys who are just coming in, everybody right now is adding these 3 triangles to their paper, or these 2 triangles to their paper, and they have instructions written on the board which you can't see. So I'm going to slide a picture of the board onto your screen, and you might have to pause the video and then zoom in on this to get any of this information. But what we're doing is we're making this line. You're finding these 2 dots from the other side of the page. Okay, this is at the bottom of the boxes 110, 111. This is at the bottom of boxes 48, 49. Find those dots, flip it back over, and then you should be able to draw these triangles. Everybody here has already added the 1 centimeter, 2 centimeter, 3 centimeter, 4, 4, 3, 2 centimeter lines in the big triangle, and they're currently adding the boxes, okay? These boxes are each 1 centimeter by 1 centimeter, and you'll see there's a pattern. Skip 2 centimeters, box, 1 centimeter, box, 1 centimeter, box, 1 centimeter, box, 1 centimeter. And then if you guys look out, you skip a space here, 2 boxes here, or sorry, 3 boxes here. You skip a space here, 3 boxes here, skip 4 spaces here, and you have 5 boxes across the top. Okay, so you guys can go ahead and try and catch that up. I'm gonna take this off the screen. And you guys will catch up here in just a sec with more instruction. All right, I hope that worked, guys, and I hope that this still works. I'll double check.
I see here. Pen, black. Super slow. Smiley face, cool. Erase the smiley face. Cool, guys.
Right here.
I'm gonna go around and check on you guys. All right, let me see what you got for papers.
I messed up.
What?
Because it wasn't. Well, that was right. That was right too. It just did line up with 14 times.
So I would guess that that's not supposed to be. That's not supposed to be.
What? Oh, it is.
Okay. All right.
1 inch.
You get there. No, you're all right. You guys, erasing's okay. You guys, it cracks me up. The true Steveness is there's many of you guys, I see your eyes, I see you look at your paper, I see you have your pen, you have your ruler, you put it in the right spot, you get ready to write, and then you just panic and look up instead of doing work. You guys, it's okay to mess it up. You guys can erase on this one. TV world can't see this, but I'll just show you mine. This train wreck has been written and erased about 25 times. Okay, I know, it's nuts, but you guys, you gotta work through this, okay? Okay, that looks excellent, and that looks fine. You just gotta go out 11 centimeters across that line. I put it across folds on purpose. Also, not helpful for TV world, but I wanna show you guys, the area we're working in today, if you just use the natural folds that you already have on here, we're working in this spot, okay? So once you guys get your triangles on there, you can fold it up. It's hard to write on that way, but you can fold it up just to see the area that we're gonna be working in, okay? Yes. Is there supposed to be a space between lines?
No, is the space.
Yeah, sure. Oh, yeah. So 3 from the bottom. Okay, and you see these cheater lines? You can just use these lines behind it, right? Just go straight across there. Okay? Yeah, reminder you guys that if you guys look at these lines, if you can see through your paper, you guys actually have, and I'm gonna make these red so that nobody copies them, but you have your boxes right behind these guys. You can look through your paper and see it. There's a box there, and then there's 2 boxes here, kind of deal. You guys can see those. Okay. You don't have to draw those dots. No. I was just letting you guys know you can see that through there. Okay.
And what about on the? So we don't draw any dots on the big triangle, but on the little triangle, we draw all those black things.
Yeah, you guys. So if you guys look in the picture or on the board, everything that's in red you don't need to draw. Okay.
So
you need to just draw the black. Yep, so that's a centimeter gap. Now, you'll notice the drawing I put on the board or from the picture I just put on the screen is very accurate, but this is not accurate at all, and it's because I couldn't break it down mathematically to fit the screen. This is like an odd size. The one on the board, I used a meter stick, and there I just cut everything in half. So where it says 11 centimeters, I actually did like 22 centimeters, which matched up with my paper just fine. I can't do that on the Promethean board because it's the wrong, like it's just not quite there mathematically. Okay. All right, I see you guys are getting these done. You guys are doing a good job. So while you guys are doing this, I'm going to talk to you about how teachers lie to kids. Because I've been lying to you for a while now, and I have to come clean. Okay? I haven't told you guys what you're doing yet, but what you're doing is you're drawing two new diagrams. Okay? To be creative, I happen to put these diagrams on trees. You don't normally find these diagrams on trees. Here's the lie I gave you guys. On the other side of this paper, we have our electron shell diagram, correct? And we have shells. So first shell holds how many electrons? 2. And in your brain right now, those 2 electrons just spin around the nucleus, correct? In a nice happy circle. Okay, next shell, how many electrons? 8. And they just spin around that in a nice circle. Okay? What you guys are going to find out is that the electrons don't actually go around things in circles very often. Okay? And so what we have to do is we have to look at the actual orbitals. Okay, so when we look at actual orbitals, they're not shaped in fun circles. There's all kinds of different shapes. I'll show you guys some of those shapes later in the lecture. But I want you guys to know these 2 diagrams are used to identify where these electrons usually show up. And so once we see that, we can get a pattern of what this atom actually looks like, or this molecule actually looks like. And then we can make better choices about what molecules are going to hook up with each other by the way they're shaped and where their electrons live. Okay? It also tells us a little bit about the energy in each atom, and we can choose the correct atoms to do the correct electrical extraction or medical kind of things. We want to find the right atoms for the right, match them up to the right diseases or right causes. Okay? So that is why we're doing all this mess, because I lied to you last week. I know, right? Teachers lie to you all the time so that you can learn something, and then we change it on you. And you go, why are you changing it? We're like, because your head would explode if I drew these diagrams instead of the periodic table. Okay?
Yeah.
Yes, right?
Oh my, Mr. Moore, okay, so is it 2 centimeters?
You go 2 centimeters and then you go to this top. Right? Okay. So this is like square. Right here is square.
Kind of.
Kind of. So okay, so the first one there, and work off that
Like,
one.
is it 2 centimeters wide? Or
Nope, it's 1 centimeter by 1 centimeter on this one.
So why does that one say 2 on the top?
Because that is 2 centimeters from the end there. Okay? If you guys do this, it's really crazy. We're not using any protractors, we're not using anything else. We're just using a ruler and these 3 points, and you guys should be able to draw pretty accurately. You guys, if you drew over this with a marker, which I don't recommend, you could lay your work over your friends, and they should be almost the exact same drawing, just by using a ruler. Now, if it's not, you're either not being very careful, you're not being meticulous with your measurements, okay? Or you're just reading things wrong, okay? That's perfect. That looks excellent. What do you got?
Well, your lines are kind of.
Okay. Excellent. Now you just got to get your lines off the side, which she's working on now. You guys are doing really good. Cool. Where's my drafting kids at? Sorry, my engineering kids. Yeah, I can tell. You guys are like, I'm done. Oh.
Good for them.
I know, right? Where's my PBS kids? You're like, give me some molecules. I don't want to measure things. Let me just stick stuff together.
No, it's more like maybe not do 3 CNAPs. Yeah. I heard we have 3 my CNAPs
What?
is still all those folders.
Did you guys hear the dates on those CMAPs?
Tuesdays.
Yeah, you guys got some days. We're going to work on some, we're going to try and build some molecules over the next couple of days to do some content. All right, you guys, almost done with these because I want to move forward. I know. You guys got to trust yourselves and just do it. A lot of you guys put your ruler down and pencil down and then don't do anything. If you have it in the right spot, just do it.
I wish I had my stuff
Mine might be a little off.
I will tell you guys, the more meticulous you are, the happier you're going to be later, okay? What do you got?
I mean, if it's big triangle, how far apart are they? Like,
They're each 2 centimeters apart.
okay.
Okay?
Just follow the lines.
Yep.
So is that,
Yes.
the triangle like roughly 1 centimeter from the
Yeah, it's almost the bottom line. Okay. And once again, you guys, I apologize for my drawing on the Promethean board because I couldn't do the math to get that perfect, so it's a little bit off. Like you'll notice this squares here. This square on your drawing is over here, and here it's next to it. It's okay, but either way it'll be fine on your drawing. But mathematically, if you do it off the board, this guy will be right on top of it. Okay.
I forgot 6 boxes.
Yeah.
One's in the middle.
How far apart are they on?
On this one, we have so there's a 1 centimeter gap here, and then all of these are 2 centimeters.
Wait, do they have to be double?
Doesn't matter. Some of you guys will leave them dotted, and then you'll choose to color them after we put some work in them. Some of them will just do them straight. Some of them will color them over the straight lines. It doesn't matter. You just need to know that those are the areas that we're working in. Okay?
Okay, that is bigger than I said.
Where's my 5?
Yeah. So that's
What do you want? Teacher salary? $5 an hour? That's just
$5. Let's see about that.
When I was in high school, I got $4.25.
Wait, how many hours are in a school day?
Feels like 12.
8 times 5.
What do you got, Rick? No, I'm going to collect them all together on today's day. Today's Wednesday. And then so you're going to do, what's the homework for tonight? 7, 2, or 7, 3, and 7, 4, right? And then homework tomorrow night is 7, 5. So when will I collect 7? Monday morning. Okay, and we're actually probably going to do an activity on Monday morning with all your outlines and your map together.
Okay, what about Kahoot?
We'll work on that. All right, guys, so I got some of you guys still scratching this out, but I'm going to start moving forward because we got to make sure we get through this today. Okay? All right, so everybody knows where we're at now. So I'm going to zoom in. All right, once we zoom in, I'm going to slide this over a little bit. And I think it's time to tell you guys what we're doing. Okay. Do you guys see where I am on the board? Here's your work from yesterday, right? Your work from yesterday's over here. And then here's your work from 2 days ago. And then here's our triangles, and here's where we're at, correct? Cool. All right, so first thing we're going to do is I'm going to tell you guys what we're doing, okay? And so we're learning how to do electron configuration. All right, so I'm going to write these, and these are about 1 centimeter tall. This is red or black? Supposed to be black. Yep, so you guys will look at the very top here. We're doing electron configuration, okay? Electron configuration. Now, on the other side of our workspace, we're also going to be doing orbital diagrams. Now, I would love to teach these separately, but they're too closely related to do that. We need to understand orbital diagrams so that we can understand how to do our electron configuration. All right? Okay, so looking at this guy, you guys will find out that this is perfectly similar to the periodic table. Totally, right? Okay, how about this? How many periods are on the periodic table? 7. Okay. So then we are going to have 7 lines on our Aufbau diagram. So down here, I'm going to write this down. It's Aufbau. It's A-U-F, B-A-U, Aufbau, and then diagram. Now, once again, most people's Aufbau diagrams are not drawn in fancy trees, but you'll have a point later, kind of. Okay? So here's what happened with Aufbau. He liked to use an orbital diagram, which is this guy right here. And he found a way to do some shortcut with some work. Okay? So the trick here is we're trying to figure out information about the electrons and write it in a different manner so that we can compare electrons or make choices on electrons for chemical combinations. Okay? And so what we had to do is we have to understand a little bit about the about the orbital diagrams here. Okay? Each of these boxes represents places that electrons can live. Okay? Now this is a diagram. It's not like the right shape or anything. Okay? But it represents where the electrons can live. Okay? And there's this guy Hund. So we're going to write H-U-N-D.
I need Nicholas Leba to report to the office.
Rule. Okay?
Nicholas Leba to the office now.
Okay.
Thank you.
Hund's rule. Hund's rule. Okay? So Hund's rule is electron levels have to fill and sublevels have to fill in order. So this would be the, we'll call this one the 1s level. Okay? This is the 1s level. All right? And the 1s level has 2 elements that live in it. Helium and hydrogen. What's hydrogen's number? And what's helium's number? 2. How many electrons live in this level? 2.
if I was to draw this diagram and I put one like half arrow up, okay, that is going to be helium. If I drew a half arrow down, this is going to be hydrogen. So in this box, I have a half arrow up, a half arrow down, and everyone would know that in the S1 level, we have 2 electrons, and that represents helium. Okay? Now, this is the part where I start making you guess some things, so we have to jump to the other chart. Okay? I'm going to make a list on Aufbau's diagram as to what goes where. All right? So, on this first space, we're going to write 1s. Then on the next one, we're going to write 2s. And then 3s, 4s. How many do you think we're going to do? 5s. We're going to do 7 of them. 6s and 7s. Just like the periodic table. You're going to see where these guys line up here in just a second. Okay? Now, the next set of orbitals, okay, are p orbitals. So we're going to go right here to the second line, and we're going to write 2p. Then we're going to write 3p, 4p, 5p, 6p, and as you guys do this, 7p. You guys can see these actually line up with the boxes behind them as well, right? That you can see through the paper. Okay? Then we drop down to 3D. So we have 3D. We have 4D, 5D, 6D. Okay? And then we're going to go over one more, and we're going to go 5F. Oh, sorry, 4F. Sorry, 4F and 5F. Okay? While you guys are doing that, I'll erase my little guy there and make it better. Make it more better. Okay? Alright, so Aufbau is just trying to keep track of where electrons live. Everybody's trying to keep track of where electrons live on this. Okay? And so Aufbau is able to combine the periodic table and the orbital diagram to make a handy little trick. Okay? So let's talk real quick about Hund's rule again. Alright? So back to the side here. Hund's rule states that orbital levels of energy will fill up at the lowest level first and then continue up equally. Okay? So in this one, this is the 1s level, just like these guys over here. There's 1 and 1. In this one, which is, guess which level this is? This is the 2s. Okay? And it fills up the same way. We're going to fill it up with this guy. So if there was 3 electrons, what element would it be? Lithium. Very good. Okay? And then if there was 4, what do we got?
Beryllium.
Beryllium. Okay? That's how we fill those out. It fills up. But then we have these derelicts. What's a derelict? Derelict's like a person who doesn't do what they normally do, right? I don't know. Derelict? Did anyone ever call you a derelict? Just me? Maybe it's because as a kid I was the only derelict. Okay. It's funny, Ryan's back with me. Okay, cool. Alright, so check it out. When you guys get here, then it changes. Before it was like fill up, fill up. But then we go to this weird thing where it starts to share. So guess which one this is? 2p. These 3 boxes are 2p, and they're going to fill up like this. 1, 2, 3. And then they're going to fill up with 4, 5, 6. Okay? This is what Hund's rule was. Okay, it basically says that there's 2 things that happen. One is it fills up at the lowest level, and second is it fills up equally across the board. Okay? So as we do this, we have S1, S2, 1S, 2S, 2P, then what's going to be the next one? 3S. Cool. And then those guys will fill up. So it'll fill up on one side first, and then back down the other side. Okay? All right, so you guys, this, I'm not going to have you fill out the whole thing, but do you understand the pattern here? Okay, so if we look at the pattern here, we're now going to have 3P, right? Wait up, 3S, 3P. Okay, all right. Now, looking at this, perfectly, this lines up perfectly with the periodic table, right? Yeah, it makes perfect sense, right? Okay, how about I draw the periodic table and show you how? Here we go. So up top, I'm going to draw a small periodic table. Wait till I'm done, and then I'm going to let you draw it, okay? All right, so here's my perfect, amazing periodic table. Does that look like the periodic table? How about this? It's weird because we're missing some boxes, like hydrogen's missing, right? Or actually helium's missing, right? I took helium and I crammed it over next to hydrogen. There's a reason why. All of these first two guys represent the S shells, and they're all going to behave the same. Okay? All of these guys over here are the next ones to fill up, and they're the P shells. Okay? And then we have the D shells. And then we have the lazy F's over here, because I just like ran out of space, so we'll just try to make him kind of sideways. These are my F shells. Okay? Alright. Do you guys recognize the periodic table? That big chunk we take out the bottom, those guys all have guys in the F orbitals. Okay? So we have S orbitals, P orbitals, D orbitals, and F orbitals. Now, once again, some of you guys are still like, why are you even telling me this? So I'm going to back up just a little bit, and I'm going to show you guys something else. Okay? I'll wait till you guys are done drawing those little guys. And then I'm going to bring over an actual periodic table setup for this, so you guys can see what I drew on the board. Hey, look. Does this look a little bit like the periodic table? Alright, what you guys will notice is, when I click on hydrogen, do you guys see how there's a big sphere in the middle? That's hydrogen. It's a sphere. Hey, look, at anybody else in this S level, look, they're all versions of spheres. Okay? So now, let's go over to the P. So the P side over here, these guys are kind of weird dumbbells, right? And then we go in here to the D's, and they get a little bit more complex. A little bit, right? And then we go down to the F's, and they get even messier. Okay? It's really hard for us to know all of those designs. Okay? So we're not going to know all of those designs. We're going to do some designs of our own. Okay? So let's take a fun break, because this is just getting way too chemistry.
Wait, what was the bottom box in the periodic?
The bottom box, this guy is F. Okay? It's a lowercase fancy F, and it matches these F's over here. Okay? And let's see, let's do orange since I don't have brown. Let's see here. Fun trees. Happy little clouds. Wait, that's something else. So people used to come over here and carve things on the tree. Like S loves circles. Fun. How about this? Let's see here. Let's do this. So you guys, what's funny is, instead of drawing all those, we have some patterns that they tend to make when they represent. And this is how the electrons tend to hang out, okay? And there's very distinct patterns for each level. So when we tag these guys up, what shape do S's usually take?
Circles or spheres. Okay. All right. How about P's? Okay. Here's how this works. Do you guys see this pen? Okay. All right. Real quick. Let's do hand gestures. What's the x-axis? Okay. What's y-axis? Okay. What's the z? Out. Okay. When we look at electrons, they actually are three-dimensional.
so this guy is just drawn, I'm going to turn my marker sideways here. This one's drawn like this, but it could have been drawn like this, but you would only see one end, right? Okay, or it could have been drawn like this. So we have X, Y, and Z. And it doesn't matter how we rotate it, it's just going to depend on which way you're looking at it, okay? These guys have X, Y, and Z, but they're a sphere. These guys have X, Y, and Z, but they're usually on one plane, X, Y, or Z. Okay? All right? Then these guys can be on two planes. They can have X and Y, and then these guys tend to go out onto their three planes, X, Y, Z, in all kinds of interesting decorations. So you guys, when you guys look at this, we have S, P's, D's, and F's. Okay? Does that make sense to you guys? Okay?
All right. So now we're going to go back to Aufbau.
So Aufbau was interested in these shapes, how they hook up, why they do these things, and electron configuration. And he got tired of using a periodic table or the orbital diagram, and he found out that if he writes this out, I don't want to go all the way up with this, kind of have to though. This will come down in just a second if you guys are missing something. For the Aufbau diagram, he found out that if you write these in 7 stacks, just like you guys do on the periodic table, and then you take a big ruler, you change to red here. Okay?
He could stripe these out, and he could use this very quickly
To identify the electrons that are supposed to be in each level. Okay? Let's see if they're not. So I'm putting these arrows through here, and these arrows point down. Okay? You're going to want the arrows.
Do they go through any specific, like, do
They do go through specifics. Look at how carefully I'm going through these guys. Okay?
And it's straight through the number and the letter, right?
Yep, it should go straight through, and you guys will see the pattern. Once I get done, if you're still not sure, you'll see the pattern here real quick. Okay, this is called the Aufbau diagram. When you combine all these things together, you can count. So, helium, how many electrons does it have?
Start to
2 electrons, right? S1, how many electrons are in the box? 2. So when we come down, we go 1, 2, and we know that it's an S1. If you had 3 electrons, you would go 1, 2, 3. What's it in? 2s. If it had 4, it would also be in 2s. If it has 5, it's 1, 2, 3, 4, 5, so we're going to be in 2p. If it had 22 electrons, it's going to go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Somebody confused?
yeah.
Check it out. 1, 2, I should use my pointer for this. Sorry, guys. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So check it out. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Do you guys see how this is working? It's a pattern. Okay? Now what's funny is, it's like it's right on the tip of your brain. Like you're like, I know. No, I don't. Okay? But that's okay because we're getting these set up today because tomorrow we're going to use them to actually write out elements in their electron configuration, and we're going to use it to write them out in their orbital diagrams. Okay? So, let's see what's up next. I know, some of you guys are struggling with this, right?
Can you please stop killing our brain?
Oh, it's okay. You don't need your brain anyways. Uh-oh, there it goes. So, all of you guys feel like doing this anyways, so we might as well destroy this. Okay, so the one thing you have to memorize in this is you have to understand that there's 4 levels, okay? S, P, D, and F. They're sublevels in the orbitals, okay? And so to remember that, I like to use this acronym, or whatever it is. Let's see. Oh, just kidding, just joking. Want that. Ooh, I don't want it to be red though. Ooh. Super Panda destroys forests. Okay, so now we're just gonna draw Super Panda on here. Let's see.
Is that an A?
I don't know.
Destroys.
Destroys. It should be an O.
Here's my question.
Is this supposed to be a Z or an S?
These are all good questions. Feel free to write it how you need to. Why a panda?
Now I can draw it.
Is it a sad panda, Mr. Moore?
It could be a sad panda. Is he doing chemistry?
Yes.
Then yes, he's definitely a sad panda.
It works though.
My Mr. Moore,
Yeah.
you were thinking to yourself,
How did I wreck
when
my
when
brain
you're
so
in college,
bad?
you're thinking, okay, my future students, what am I gonna do for them? And you're thinking, panda.
Can I tell you guys the truth? I have had a lot of amazing teachers, and they taught me a lot of stuff. But how much of that do I remember? But when something stupid happens, totally remember that. Think of the most embarrassing thing that happened to you in middle school.
Oh, God.
Yeah, you remember that vividly, right? If I can make everything stupid, like this cape that says Super Panda, right? That's dumb. But you might be like, why do I think of pandas? Well, maybe it's because SPDF. Okay, those are your subletters. Or maybe it's because it's time to defeat the Huns. Nobody? Just move on? Okay, whose rule is it up here? Huns rule. Huns rule tells us that we fill up the lowest ones first, and then they spread out equally when we get to the degenerate levels. Okay? Alright? So, you guys, when we look at this, I know it sounds dumb, and it might even, people would consider it racially insensitive to say Super Panda destroys forest. But, you guys will remember this crap. Okay? And what's really funny is right now it's crap in your head because you have no idea what to do with it. Tomorrow, we're going to use both of these diagrams to represent hydrogen, boron, neon, and I don't remember what. But we're going to do 4 elements. We're going to write them in we're going to write them in electron notation, and then we're going to write them in orbital boxes so that you guys have a good understanding of how this works. Okay? Yes?
What does it actually like look like a panda?
Because mine is.
You have questions about how to use this,
Can I
right?
look at mine?
You're figuring it out. I see you. Tomorrow we're literally going to do it. I think you guys might already understand. Okay? And when you start to use it, you're going to start to understand how it actually directly correlates to the periodic table. And all because of the nonsense. Okay? Alright, you guys, what's your homework tonight? 7.3, 7.4.
Can I draw a word box saying RAR?
Yes.